Have you ever stopped to wonder how your favorite coffee shop gets your drink out so fast? Or how a busy hospital manages to treat hundreds of patients a day? Or heck, even how something as complex as Congress actually functions? Well, it turns out they all share a secret language, a hidden structure. Today, we're going to pull back the curtain and show you how to see these systems using the incredibly powerful lens of operations management.
All right, so here's our game plan for this explainer. First, we're going to see the world in a new way, as a collection of processes. Then we'll break down what those processes are actually made of. We'll cover the 3 vital signs you need to measure any process, and then we'll reveal a secret formula that connects everything. By the end, you're going to have a whole new way to see the world around you.
Okay, first things first, we need to kind of shift our perspective. See, most of the time, we're inside a process. We're the customer in line, the patient in the waiting room. But to really get what's going on and to see how things could be better, we need to step outside and become a process observer. I mean, seriously, think about it. Getting your driver's license, waiting to see a doctor, even just getting through college, so much of our lives can feel like we're just waiting in one line after another. But here's the cool part. These aren't just random frustrations. They are all processes. And once you see them as a process, you can start to understand them, measure them, and even improve them.
So, what is a process, really? It sounds complex, but it's actually super simple. It's just a set of steps that takes some inputs, does some work on them, and produces some outputs. That's it. A hospital takes in sick patients, the input, and provides care, the work, to produce healthy patients, the output. It applies to literally almost everything.
So, if everything's a process, what are the actual moving parts? What's the anatomy here? Well, let's break it down. It's way simpler than you might think. It really just boils down to a few core building blocks.
And here they are. This slide lays it out perfectly. Every single process has these 3 essential steps. You've got your inputs, in this case, patients walking into a hospital. Then you have the transformation, the part where value gets added, like the radiology unit doing an X-ray. And finally, you get the outputs, the treated patients who can now go home. This simple structure, input, transformation, output, is the backbone of everything from making a sandwich to passing a law.
Okay, this next part is really important. To understand any process, we first have to decide what it is we're actually tracking. In operations, we call this the flow unit. Think of it as the thing moving through the system. So in a hospital, the flow unit is the patient. At a university, it's the student. It's the basic thing you're counting as it goes from start to finish. All right, so once we know our flow unit, the thing we're tracking, how do we measure the health of the process? Well, just like a doctor checks your vital signs, your heart rate, your blood pressure, we have 3 key metrics to check the performance of any system.
And this table breaks them down beautifully using a simple coffee shop. Let's walk through it. First, we have inventory. Now, this might sound weird when we're talking about people, but inventory is just how many flow units are in the process at any one time. So it's the number of customers in the shop. Simple. Next up is flow rate. That's all about speed. How fast are we serving people? Customers per hour. And finally, we have flow time. This is how long one customer actually spends in the entire system, from the moment they walk in to the moment they walk out with their coffee. These 3 measurements are the key to everything, and the way they're connected is where the real magic happens.
And now for the big reveal. There is a simple, almost magical formula that connects these 3 vital signs together. It's called Little's Law, and it is one of the most powerful, fundamental ideas in all of operations. It lets you diagnose problems and understand the behavior of pretty much any system you can think of. This is it. Looks simple, right? But it's so incredibly powerful. Little's Law says that the average amount of inventory in a system is just its average flow rate multiplied by its average flow time. Now, here's why that's so amazing. If you know any 2 of these numbers, you can always figure out the third. Always. It's like a secret key. We can just shorten it to I equals R times T. And this elegant little equation explains the behavior of countless systems, from bakeries and car factories to software companies and, get this, even the United States government. Seriously, let me show you. Let's apply this to a system you might not think of as a process, the U.S. House of Representatives. Okay, so what do we know? We know the inventory, I. It's fixed by law at 435 members. And from looking at data, we know the average flow rate, R. About 26 new members are elected each year. So the big question is, what's the average flow time, T? In other words, what's the average number of years a person serves in Congress?
Well, using Little's law, we just rearrange the formula. Flow time equals inventory divided by flow rate. So we take 435 divided by 26, and we get an average tenure of 16.73 years. That is a long time, and it's an incredible insight that we got from a formula that fits on a napkin.
Now, and this is a really crucial point. Little's law is all about averages. It doesn't tell you how long a specific representative will serve. Of course, some people serve for 50 years and some only serve for 2. The law can't predict any single person's career, but what it does, perfectly, is calculate the average for the whole system.
So now you have it. You have this entire framework. You understand processes, flow units, the 3 key measurements, and the secret law that connects them all. You basically have a new kind of X-ray vision to see the hidden mechanics of the world all around you.
So let's just quickly recap your new toolkit. Number 1, see the world as a collection of processes. 2, know that every process just has inputs, a transformation, and outputs. 3, you can measure any of them using inventory, flow rate, and flow time. 4, Little's law, I equals R times T, shows you how they're all connected. And most importantly, this framework is your key to finding bottlenecks and spotting opportunities to make things better everywhere.
And that brings us to the final thought. I want you to think about your own day, your morning routine, how you get work done, even how you do your grocery shopping. What's one process in your life that you can now see in a totally new way, and maybe, just maybe, even improve using this powerful new lens? Thanks for joining us.